All right then, 7.3 multiplying and dividing polynomials. Multiplying and dividing polynomials. So it would be great if you went back and reviewed stuff on factoring polynomials, because you're going to use that a lot. In this book, it's section 4.4, but factoring polynomials, you definitely need to review that, buddy. Okay. In your notebooks, also on page 376, you're going to put this in your notebooks. A rational expression is a fraction whose numerator and denominator are non-zero polynomials. The domain of the rational expression excludes values that make the denominator zero. A rational expression is in simplified form when its numerator and denominator have no common factors other than 1 and -1. Bam. There. So here's an example right here. AC in the numerator, BC in the denominator. The C's cancel and you're just left with A over B. Okay, so let's go straight to the problems. This stuff, it's going to ask you to simplify the expression if possible. So factoring, this is what you do with factoring. First, is there a common factor? Then look for difference of squares or difference of cubes or addition of cubes. That was step 2. Step 3, X box, because there's 1, 2, 3 terms. Then look for the box method. Box method is step 4, because there's 1, 2, 3, 4 steps there. Okay. So when you do this, materials, first factor the numerator and denominator. So in this one, can you factor it out? Common factor is x squared on the top, so I factor out an x squared on the top. The denominator cannot be factored, so you do that. Now, can you divide out any common factors? Can you divide out any common factors? Where's my purple? Oh, here we go. Purple falcons. Can you factor something out? Yes, x squared and x to the third. So there's x squared up here. There's more x, there's 3 x's in the bottom and there's 2 x's on top. So 2 of the x's on top and 2 of the x's in the bottom can cancel. So those 2 x's on top cancel that 2 x's in the bottom. You still have one more x in the bottom than the top, so that's why that x is still there. Okay, so that when you can you simplify it anymore? Can you divide out any other common factors? No. So that's simplified. When you write it, it looks like this. Now we're so close to being done. Can you divide by 0 in mathematics? No, you cannot. It's not allowed. When is this denominator going to be equal to 0? Okay, let's do it one at a time. When is 2 going to be equal to 0? It's not. It's a constant. That's constantly going to be a 2. When is x to the third equal to 0? When x is 0. When x is 0, that becomes 0. You divide it by 0, which is undefined, so x cannot be a 0. So x cannot be 0. Is there anything else there? Nope, that's it. This is your answer. Boom. Done. Next one. Go to the next problem. The next problem simplifies these materials. Simplify these materials. Factor the top, factor the bottom if you can. So can we go to the top? When you factor that, you get this. Again, you need to go back to factoring polynomials because we don't have time to do that right here. So the top, when you factor out that, you get this. The bottom is actually x cubed minus 3 cubed. This is now a difference of cubes. The difference of cubes. Okay, so right there, difference of cubes. Something cubed minus something else cubed. That's what we're going to use. Okay, so the top has not changed. The bottom, when you factor that out, you get this. Doink. You get that. Can you factor out this anymore? No, this portion, the cubes, this portion cannot be factored out anymore. If you factor out this, you'll get an imaginary number, but we're not looking for imaginary numbers. We only want real numbers here. So next thing, can you divide out common factors? Can you cancel out these common factors? Is there anything common in both of those? Actually, yes, right here. X minus 3 on top, and the exact same thing, x minus 3 in the bottom. Okay. So actually, just go over here and do that same thing. This is 3 squared, by the way, which is 9. So it looks like that. That's a boo-boo. That cancels out that. Okay. And, oh, that was the answer. I should have went that, cancels out that. What did I do here? So yucky, yuck, yuck, yuck. The answer is x to the 4th. Here, I should have done this better. That's a bad job there. Bad teacher. Plus 3x plus 9. So this is on the numerator. That's in the denominator. And the restrictions. X can, so you look in the denominator. X cannot be, so it's easy here when you're factored. When is this going to be 0? This whole quantity right here, that whole quantity is 0 when x is 3. When x is 3, that quantity is 0. You're dividing by 0, which means x cannot be 0 because you're dividing by 0. Over here, this part right here, if you factor out this, if you use the quadratic formula, you're going to get an imaginary number, and we're not worried about that. So your answer is that right there. Bada boom, bada bing, bada bang. Okay, next one. Take this, simplify it. Okay, when you simplify the stuff, factor the top, factor the bottom. Factor the numerator, factor the denominator. A lot of factoring here. You definitely have to review factoring. The top, 1, 2, 3, 4 terms. I'm going straight to step 4 and doing the box method. And that means the top, when you do that, after you factor that, you get this. Okay, the bottom, that right there, you can factor out 7 plus 4 plus 1 is 12. Just, okay, 3 goes into that. 3 goes into 12, so I know that 3 goes in that evenly, 3 goes into 27, so you can factor out a 3. So that's what I did right there. So 3 times, 9x to the 4th. I just took that. This right here is now going to be something squared minus something else squared. That is a difference of squares. And that, you get this. Difference of squares. It's this right here, difference of squares. Okay, something squared minus something else squared. Okay. Now, can you cancel that, or can we factor anything else? No. Okay. So let's correct, can we cancel out anything here? Is there something identical on the top? Yes, right here and here. Bada bing, bada boom. Okay, so that's what's remaining. So you have that. So you have x minus 1 on the top. You have that 3, you have 3. Okay, can you factor that anymore? Nothing can be factored, nothing else can be canceled. Now, what are the restrictions? When is the denominator going to be 0? So 0. So when is this denominator going to be? Right here. When is the denominator going to be equal to 0? When is this going to be equal to 0? It's not. 3 is a constant. It'll never be equal to 0. That's why it's called a constant. When is this going to be equal to 0? 3x squared minus 7 equals 0. 3x squared, add 7. Divide by 3 on both sides. Take the square root of both sides. X equals plus or minus. There we go. X cannot, when x is plus or minus the square root of 7. Oh, there's a radical in there. I can't, that's not simplified yet. Square square root of 7, square root of 3. Where'd the pin go? There it is. Square root of 3, square root of 3. And we get square root of 21 on top. You get 3 times 3, sorry, square root of 3 times square root of 3 is 3. Square root of 12 times square root of 12, 12. Square root of 57 times square root of 57, 57. Square root of 7 times square root of 7, 7. Square root of 3 times square root of 3, 3. So x cannot be square root of 21 divided by 3. Okay, this is your answer. Boom. Next one, let's go turn it over. You see all that stuff yet? We have this. Factoring. Simplify this mess. Okay. This is, oh, we're multiplying. Oh, you know when we're multiplying, all it is the same thing as saying, simplify that mess. That's it. There's nothing really special about that. It looks very similar to what we've done in the past. Okay, so can we factor out anything here? No. Can you factor out anything here? Nope. Can you factor out anything there? Nope. Can you factor anything there? Nope. So all this stuff here, there's no common factors, there's no difference of squares, cubes, x box, cannot do that, cannot do box method either. Okay. None of this stuff you can do. Okay, can't do any of that stuff. So, next thing is, hey, can we start canceling? Sure thing, boss. Sure thing, boss. What can we cancel out here? 6 goes into this, 6 goes into that. 6 goes into that once, 6 goes into that 8 times. We have x to the 5th on top. We have x to the 3rd on the bottom. 5. There's 5 more x's on top than on the bottom. So all of those are gone and 2 of these are remaining. So that's x squared. We have y and y. Y to the 3rd on the top. There's 1 more y on the bottom than the top, so all of those are gone, and now this becomes just y to the 1st. Y to the 1st, y to the 1st, those cancel each other out. X squared on top. Is there any more x's on the bottom? Nope. So you're going to get an x squared on the top. You have an 8 on the top. You have a y squared on the bottom. And when you do that, you get 8x to the 4th. Wait a minute. Oh, so here's x squared. Here's another x squared. So that's x to the 4th. And that's why. 8x to the 4th on top, y squared on the bottom. Now, restrictions. What are the restrictions? Okay, when is this going to be 0? When y is 0, that's 0. So y cannot be 0. When is that going to be equal to 0? It's not. 6 is number 0. 6, that's why it's constant. When is that 0? When x is 0, the x to the 3rd is 0. So x cannot be 0. When y is 0, you already got that right there. This is your answer. Okay, now, if you don't like doing it that way, you can do it the long, hard way, which is this. There's 5 x's. 5 x's right there. There's 3 y's right there. There's 2 x's right there, and there's 1 y right there. 4 y's on the bottom. There's a 6. 3 x's on the bottom. 2 y's on the bottom. 3 y's. Don't cancel out the 3 y's there. Not the 3 y's min. It's just the letter y. 2 of those x's cancel out 2 of those x's. 1 of those x's cancels out 1 of those x's. This y cancels out that y. So there's 6 and 48. 6 goes in there once. 6 goes into there 8 times. On the top we have an 8. We have an 8 in the top. How many x's do we have? 4 x's. That's where x to the 4th comes from. Anything else on the top? No. On the bottom we have 1, 2 y's. That's where the 2 y's come from. That's your answer. Next one. we're going to multiply this right here. See, multiplies. Zoom. There we go. Looks a little neater. Okay, I'm going to take that. Move this over so it's in frame. There we go. So boom. When you multiply this stuff, can you factor the top, factor the bottom, factor the top, factor the bottom, if you can. This is 3 terms x box, 2 terms common factor, 1, 2, 3 terms x box, 1, 2, 3 terms x box. Boom, there you go. That, when you factor it, you get this. The bottom x box, you do this. Common factor is 2x, you get that. The numerator. The denominator, 1, 2, 3 terms, you do the x box, you get this. Now, take that. So it's the same stuff. I'm just going to start canceling things. Is there something on the top that is the exact same thing on the bottom? X plus 4, is there an x plus 4 on the bottom? No. X minus 1 on top, is there an x minus 1 on the bottom? Yeah, it's the exact same thing. Not kinda, exact. Those cancel. Is a 2x on top? Is there a 2x on the bottom anywhere? Nope. X plus 2, the quantity x plus 2 on the top, is there a quantity of x plus 2? Yes. Can you cancel out anything else? Nope. So on the top you have x plus 4 and 2. So we're going to put the 2x out front. That goes on the top in the numerator. On the bottom we have an x plus 2 and an x minus 3. There you go. Okay. So this is what happens. Now we still have to do the restrictions. When is just this portion, I'm just worried about the denominator. Who cares what happens? In the top, you can get a 0. If you have a fraction, a can be 0, but the bottom cannot be 0. If a is 0, 0 over 4, hey, the answer is 0. But if you have this, 4 divided by 0, this is undefined. Doesn't work. So the bottom denominator cannot be equal to 0. Undefined. It's against our math rules. When is just that quantity equal to 0? When x is negative 2. So x cannot be negative 2. What about here? Negative 2. Already got that. When x is positive 3, cannot be a positive 3. Cannot be a positive 1. Dun, 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 dun. There we go. We have all our values. Bada bing, bada bang, bada boom. Oof, come on. There we go. We did these already. Next. Dos más. 27b. Find the quotient. Find the quotient. We're dividing. So this is like kind of like saying 8 over 2 divided by 1/4. Instead of dividing by a fraction, we change the division to a multiplication and we take the reciprocal, then start seeing if you can cancel. We're going to do the exact same thing right here. So I'm going to rewrite this. This does not change. The first one does not change. Okay. The second, you're going to change this to a multiplication. And this, you just take the reciprocal. Okay. Now, can we factor anything on the top there? Nope. Can we factor the top here? Nope. Can you factor that denominator? Nope. Can you factor that? Nope. So we take these materials. Also, what can we cancel? This W and that W. X and X. Which has the more X's? Which has more X's at the bottom? So one of those. And there's going to be one left on the top. There's an X to the first remaining there. Should we do anything else? No. Ooh, 4 and 8. 4 goes into there once. 4 goes into there twice. Okay, so on the top we have a W to the third. On the bottom we have a 2. There's an X there and an X there. On the top we have a W to the third on top. We have a 2 in the bottom. We have an X and an X. Becomes X squared. That part's done. What are the restrictions? Okay. X cannot be 0. If X is 0, that quantity is 0, so X cannot be 0. W cannot be 0. Right here, W cannot be 0. Already got that. When you flip that, what about here? When is that equal to 0? 8's always 8. That's why it's called a constant. When is that? We already got that. And that's it. Boom. Bada bing, bada bang, bada boom. Easy peasy. Yeah, right. The trouble you're going to have right now, factoring. You have to go review your ability to factor. So review the chapter lesson on factoring polynomials. I think it was 4.4. Okay. Here's another one. Oh my gosh. Flimity flamity. Oh, what the heck? How do you do this? Oh, it's just dividing by a fraction. Remember, this is just going to be a function, so we're going to multiply. We're going to change this fraction instead of divide, change to a multiplication, and take the reciprocal of this one. So when you do that, it looks like this. So all I did is take this, and you take the reciprocal. Reciprocal. You may call it flipping it over. I don't. I'm going to call it reciprocal. Okay. Now, can you factor the top, factor the bottom, factor the top, factor the bottom? 1, 2, 3 terms. X box. Okay, that one. This top, when you 1, 2, 3 terms X box, when you factor it, you get this. 1, 2, 3 terms X box. When you factor it, you get that. Okay. Next one. The top, 1, 2, 3 terms. When you take that top, you get this, the X box, and the bottom, 1, 2, 3 term X box, you're going to get that. There you go. Now, the factoring, that's all. Factoring is done. Do we have any common terms that we can cancel out? There's an X minus 8 on top. Is there an X minus 8? Ooh, that's close. It's not the exact same thing. Cannot cancel it out. It's not the exact same. Do not cancel. X plus 5 on top. Is there an X plus 5? Yep. X plus 10 on the top. Is there? Yeah, on the bottom. X plus 2 on the top. X minus... They're not the same. Not the same. Cannot cancel. Is there anything else? Okay, nope. X plus 8. X minus 8 on the top, and an X plus 2 on the top. So you have an X minus 8, X plus 2. Why did I do that? Okay, that's what we had there. You have an X minus 8 on the top, and that X plus 2 on the top. On the bottom, we have an X minus 2. We have an X plus 8. These are not the exact same thing. These are not the exact same thing. Now, if you wanted, you could put an X minus 2 here, and on this side, put an X plus 8. Remember, multiplication, the order in which you multiply does not matter. Same thing for addition. Okay, that part's done. What about the restrictions? Okay, here, when is this denominator? When is that going to be equal to 0? When X is negative 10. So X cannot be a negative 10. What about right there? Cannot be a 2. Cannot be a negative 8. Cannot be a negative 5. Anything else? Okay, now keep in mind, this right here was in the denominator at the beginning, so that part right there, this stuff right here, this used to be in the denominator, so you have to take care of this. When is that equal to 0? When X is negative 10, we already got that. This one, when X is negative 2, we already got, and a negative 2. Now in college, they want you to do it like this. What's the smallest number there? Negative 10. Got that one. Negative 8 goes next. Negative 5 goes next. Negative 2 goes next, and then a positive 2. So this is your answer. And we're done for today's Boom. 25 minutes flat.